Welcome to your first section of your recorded lectures in Fundamental Math 108. We're starting with section 1B. I'm going to preface this really quickly. The first thing you should do before listening to this recorded lecture is read this on your own. You'll get a lot more out of the lecture than if you just jump into it. We're going to start. I like to organize my notes and the section in an outline. So here we're going to start at Roman numeral 1, propositions. Now you would have already read this, and if not, press pause and come back to this, and then read your section and come back. So the first Roman numeral is propositions. A proposition is a statement that makes a claim, and a claim therefore has a truth value, so a proposition has a truth value, either it's true or false. Here's some examples. The first one, Robert is taking notes. So this is a proposition. Yes, it is a proposition because Robert is either taking notes or he's not taking notes, and it has a truth value. The second one, I ran to class. Well, either you did run to class or you didn't. Therefore, it has a truth value, and this is a proposition. What are you doing? For the third example, this doesn't have a truth value, it's a question, so this is not a proposition. If you hear northwest of McDonald's, well, first of all, this is an incomplete sentence, so we don't know what's northwest of McDonald's. So to our knowledge, there is no truth value, and therefore it is not a proposition. 5 times 15 equals 300. Again, a proposition. It has a truth value. 5 times 15 does not equal 300, it equals 75. And the truth value is false, so this is a proposition. Going on to the next section, B, a negation. This is the opposite of a proposition. So if we take our first proposition, Robert is taking notes, and negate it, or the negation is, Robert is not taking notes. It also has a truth value, and the truth value will be opposite of the original proposition. 5 times 15 does not equal 300. Again, the negation of the example number 5. If your proposition is true, then the negation is false, and vice versa, like we discussed. If Robert is taking notes, this proposition, if this one's true, then Robert is not taking notes will be false, or vice versa. Neither both can be true or false. Also, please note that from now on, we will often see not symbolized by our little squiggle that you can find when you do your own homework on the keyboard just under the escape button to the top left. Now we're going to move on to truth tables. I think this is probably the trickiest part of section 1B. The truth table represents all possibilities and combinations of truth values. So we're going to take our proposition P. We're not going to define what it is, so we're just going to keep it P. And its negation, not P, or using our symbol, negation or not P. If P is true, then the negation, not P, is false. So if Robert was taking notes, and the negation is Robert is not taking notes, then that's false because he was taking notes. Again, if the proposition, the original proposition, is false, then the negation is true. So if Robert wasn't taking notes and the proposition said Robert was, then it's false. And the negation is true. Let's move to the next example, C. Our proposition P is Betsy is the fastest runner on the team. So not P, where the negation of the above proposition is Betsy is not the fastest runner on the team. If not P is false, then Betsy is the fastest runner on the team. So if we come up here, not P, if this proposition or the negation of it is false, then the first one, or the proposition, is true. Let's move on to D, a double negation. I can't say I don't agree with you. So is the speaker agreeing with you or not? double negations are kind of tricky. You hear them a lot and you don't know how to answer the question. So let's break it down, because in our arguments that we'll discuss later, you need to know what the negation is. I like to think of negations, or our little negation sign, exactly like a negative sign. When I have two negatives, it makes a positive, or a negative times a negative, I get the positive, or the original sentence. So let's go back to our double negation up here. I can't say that I don't agree with you. So my can't and my don't cancel each other out like two negatives being multiplied, and I can even ignore those and say, I say that I agree with you. So yes, the speaker is agreeing with you. Now, how does that apply to what we're doing? Well, we're going to fill in more truth tables with more possibilities and combinations. So we're going to use our undefined proposition P, and then we want to fill in the truth table for our negation not P, and a double negation not P. So all the combinations for P that we have are true or false. And we've learned that not P has the opposite truth value of the original proposition. So if P is true, then not P has to be false. And not P, when P is false, has to be true. Now going on to the double negation, we have two ways of looking at it. We can either come back to the original, P, or we can look at the not P. Remember, a negation does the opposite of what the truth value was previously. So I can just say my not, or my not of the not, changes this truth value to be true. Or you can also think of it as two negatives being multiplied together and they cancel each other out. So this really is the same truth value as P, true. Or again, you can think of it the other way, which makes this one false. I also have the answer over here just in case you needed to see that. My next proposition. My opinion is that it's unlikely that there is no association. So I have how many negations in here? Unlikely, no association. A negative times a negative makes a positive, and they cancel each other out. So I can even read this sentence by just ignoring those. My opinion that it's likely that there is an association. So that there is an association according to this person's opinion. Next one, legal principles weigh heavily against overruling Miranda now. So our question is the judge supporting or opposing the Miranda decision? Let's come up and find all of our negatives. Legal principles weigh heavily against, so that's in the first negation. Overruling, so the second negation, Miranda now. So I have two negatives. I can cancel them out, and we're left with the against and overruling canceling, which means if you're against the overruling, that means he is in support of the Miranda decision. All right, let's move on to Roman numeral 2, logical connectors. This is a compound, when a compound proposition contains and, or an if-then. The first connector that we're going to talk about is and. This is called a conjunction. So I take two or more propositions. In this case, we're going to be using P and Q, and with the and conjunction, both must be true for the combined statement to be true. So if we take something, the proposition, my husband is tall and handsome, we have two propositions. My husband must be tall and he must be handsome. So for my conjunction to be true, by the way, he's 6'3" and he's pretty hunky, so therefore my conjunction is true because both the propositions are true. However, that is kind of subjective, so we'll move on to the next part. We'll talk about objective and subjective later. Truth tables of P and Q. So now I'm going to do a couple of logical connectors. There are lots of different combinations with P, Q, and now we're going to be adding in the truth table for the conjunction. So we need to know how big to make it. So this is just a little hint. You take all of your different propositions and each possibility, so I have my proposition P, it has two possibilities, true and false. My next proposition is Q. It also has two options of being true and false. Multiplying those together gives me 4 rows. Then you want to put your header on top, which would be your proposition, your next proposition, and the rest of the truth table of what you want to look at. So negations, and in this case, a conjunction of and. So let's go ahead and fill it in. I know the answer's over here. Don't look at that for now. It's just to kind of help the notes flow better. So let's talk about the P first. I have two options. It can be true and false. But I also need to make those options connect with the conjunction or the proposition P. So my first option for proposition P is true. Now the option I can combine with Q is also true. I know we have our conjunction, we'll come back to it later. So the next combination, P can be true and Q can be false. We can have that combination. The next one, since I've done all the possible combinations of P being true with Q being true and false, I now have the option of P being false, and then Q can be true. And then the last combination is if P is false and Q is also false. Now remember, with this conjunction, to fill in this side of the truth table, they both have to be true. So if P and Q are both true, as shown here, true and true, then the conjunction is also true. The one below, true and then false, then the conjunction of P and Q has to be false because they both have to be true. And we can go ahead and fill in the rest of that because none of them are a combination of both being true. Okay, let's go ahead and find some examples. The capital of France is Paris and Antarctica is cold. So I have two propositions. The first one stating that the capital of France is Paris. The second one is Antarctica is cold. Is the capital of France Paris? Yes. Is Antarctica cold? An understatement, but true. So therefore, the conjunction and here, the whole conjunction is true. All right, our second example. The capital of Idaho is Boise, and the capital of Florida is St. Jerome. So here's my conjunction and. Now let's talk about the truth value of both propositions. The capital of Idaho is Boise. Yes, that's true. The capital of Florida is St. Jerome. False. So my conjunction, the whole thing is false. Even though the first part is true, the whole conjunction is false because both need to be true. Okay, let's kind of go out on a limb and try a truth table with 3 propositions. Now to help you kind of get started to write it out, remember to figure out how many rows you have. P has 2 options, Q has 2 options, and R has 2 options. P can be true or false, Q can be true or false, and R can be true or false. Multiply those together and you get 8 rows. And then you tack on your header so that you know what each column represents. So now I'm looking for all the different combinations. I know the answer's on the side. That's just to help your notes flow if you want to kind of skim through the lecture. All right, so P, it can be true. I always start with true because that's nice. In fact, my first combination, I'm going to just make them all true. We'll come to the conjunction afterwards. We want to find all the different combinations. So I can have true, 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 or I can have true, true, false. Or I can have true, false, true. Or I can have false, true, true. Then, let's see the next combination. Let's try false. No, I want to do, yeah, false, false, true. Then false, true, false. And my last combination is false, false, false. Now I know that I have 8 rows and I know that each of these are different. So when I'm filling that in, I know that if I haven't repeated anything, then I have all the combinations because there's only 8 combinations available for the P, Q, and R. Now we're going to come over here to the conjunction. Now, for a conjunction to be true, we need to have all of them be true. So this is true, and we can just fill in the rest. Everything past that point has to be false, because there isn't one where all of them are true. All right, let's move on to the second conjunction, or the second logical connector, or. This is a disjunction. There are two different types of or, the inclusive or the exclusive. An inclusive is either or both. So you can have one or the other or both and it's good. Exclusive means it's one and the other, or the other, but it can't be both of them. So let's kind of work through an insurance policy. If I have a policy for fire, flood, or theft, hopefully this insurance policy is inclusive. So if I have a fire and a flood going on at the same time, or a theft, let's say all three are happening, the insurance company is not going to say I'm only going to pay for one of those. It's either or all of them. So it's inclusive. In logic, we're also going to assume that all of the ors from now on are inclusive unless you're told otherwise. So for a disjunction to be false, all of your propositions must be false. So it's a little opposite of the conjunction. So if I take the statement, her name is Sarah or Samantha, and we're just going to kind of assign these propositions letters. So Sarah will be the P and Samantha will be Q. And let's find all the different ways to fill up our truth table. I can have, let's go back and just make sure that we're okay with how big the truth table will be. I have two options for P, so 2. I have two options for Q, it's 2. 2 times 2 makes it 4. Just double check, I have 1, 2, 3, 4. I have 4 in there, so I'm good to fill in all of the different possibilities. So I always start out with true 2 because that's fast. Moving on to the next one, true, false. The next, false, true. And the last, false, false. Now, for this to be false with an or, all of them must be false. So if I have both of them being true, her name is either Sarah or Samantha or both. Well, it can't be both because usually it's one or the other. So this is going to be true. Your statement's true. If it's Sarah and her name is Sarah, your statement is still true. You were right. Her name is Sarah or Samantha. Now, if her name is Samantha, you're still correct. It's either Sarah or Samantha. Now, if it's not Sarah and it's not Samantha, then the whole statement is false. Let's move on to our third example. Airplanes can fly or cows can read. Remember, this is a disjunction, or. And for a disjunction to be false, all of the propositions must be false. Okay, so let's talk about the truth value of this. Airplanes can fly. True. Cows can read. False. So it would be my true, false line here in my truth table, and the whole proposition is true. This disjunction is true. Now I'm going to show you something about how I would like you to circle your answers. In paperwork, you usually circle your answers, but because we're using computers, something I like you to do just to set your answer apart would be to highlight it with a color. You can do it a different color. Oh, it's not working. A different color, or maybe a highlighter. Change it a different color that way. Just some way to distinguish your answer from the rest of the text. It makes it stand out so I can easily find your answer when you type and send in your homework. Okay, the fourth example, internet research. Doing a report on the federal debt that appear in either the Time or Newsweek between 2004 and 2006. So in general, an and will narrow your search and an or will widen the search, and you need caps. So if I want something between 2004 and 2006, I'm going to do 2004 and 2005 and 2006, a conjunction. Now I want either Time or Newsweek. So my conjunction of or. Get your parentheses for all of the different titles. I want federal or United States or government. Then I need that combined with a conjunction of debt or budget. This will find any different combination that you have of federal and debt or federal and budget, United States and debt or United States and budget, government and debt or government and budget. And that's how we can make internet searches a little faster. Our next logical connector is the if-then or the conditional statement. If P, then Q. P is your proposition. It's also called the hypothesis or antecedent. Q is the conclusion or the consequent. Our first example, a politician states, if I am elected, then minimum wage will go up. P and Q are true. That means that the election occurred and the politician was elected. The politician kept the promise and the wages did go up, and the conditional statement is true. And that's how we find the truth value for a conditional statement. The next one, if P then Q. If P is true, but Q is false. Let's go back to my politician idea. That means P was being elected, so the politician was elected. Q being false, or the conclusion was the wages did not increase, the politician did not keep the promise. So a claim is, or the whole conditional statement is false. And I'm going to go ahead and change these to make that the answer, kind of make it stand out. Let's try the next possibility. If P is false and Q is true. For the politician example, P is false. The politician was not elected, but Q is true. Minimum wages did increase. So what the politician wasn't elected, wages increased. This politician didn't break the promise. This politician was never elected. So even though wages did go up, the politician didn't break the promise. So his or her statement is true. We have nothing to suggest otherwise, that this politician was lying or didn't break their promise. So in an if, then, or a conditional statement, if I have false and then true, the whole statement is true. The next one, the other option is if P is false and Q is false. Using the politician idea, if P is false, then the politician was not elected. And Q being false, then minimum wages did not increase. Is that the politician's fault? No, the politician wasn't elected. So we have no way of saying that they wouldn't have or didn't keep their promise. So even though I have an if-then statement with the proposition or the hypothesis or the antecedent all being false and the conclusion even being false, the statement is true. This is the hardest one for most people. When they get to this, they're okay that if the person was elected and they kept their promise, it's true. They didn't keep their promise, or they didn't keep their promise, they got elected, then of course the claim is false. These ones, when the person isn't elected, or when you have a false proposition or hypothesis and the conclusion is different, the answer is true. The whole conditional statement is true. Let's go ahead and try making a truth table here. Give us some room. So again, I have two propositions, if P then Q. So I have two options for P, two options for Q. So I have 2 times 2, which is 4. All right, I have 4 rows here, and let's go ahead and fill in all of our combinations. So I have true and true, our favorite one, then true and false, that's my next combination. True, or no, I have all of my combinations with true being first, false and true, and then false and false. So to fill in the rest of our truth table, We have an if-then statement. So I always like to think back to the politician example. If the person was elected and they kept their promise or the wages went up, then I have true and true, and the whole statement is true. The next one, if the politician was elected, so the first one happened, it's true, but wages didn't go up, then the politician didn't keep their promise and their statement was false. The next one, the politician wasn't elected, so the statement's false. It doesn't matter what happens after that. We have nothing to prove or have no proof otherwise that their statement wasn't true, so the statement is true. The next one, if the politician was not elected and wages didn't go up, we still can't say that they made a false statement, and so it has to be true. Let's go on to our next example. That's kind of the hardest one to fill in right there. Our second example, if 2 plus 2 equals 5, then 3 plus 3 equals 4. So I have my conditional statement, if, proposition, then proposition. Here is the first one. I have 2 plus 2 equals 5. False. So I'm going to put that in here. False. Then 3 plus 3 equals 4. Also false. But remember, if I have a false statement in a conditional, the whole proposition is true. Let's take that away and circled. My whole proposition is true. Some alternative phrasing that you might see for conditionals are P is sufficient for Q. And remember, it's if P then Q. And if you see something like this, it's to your advantage to go ahead and rewrite it to say if P then Q. P will lead to Q is another way of writing if P then Q. P implies Q. Q is necessary for P, so this is when the conclusion comes first and then the hypothesis. Q if P and Q whenever P. So if we have a statement, a rise in sea level will devastate Florida. So I want to rewrite this as an if-then statement. So a rise in sea level will devastate Florida. It's already in the order, so I have the proposition first, conclusion second. So I can write it, if the sea level rises, then Florida will be devastated. The second example, a red tag on an item is sufficient to mean it's on sale. So if we come up here, remember is sufficient, we have P first, then the conclusion. So we can say if an item has a red tag, then it's on sale. And the third example, being male is necessary for being President of the United States. Necessary is here. That means that we have the conclusion first, and I need to flip-flop these. So I say if a person is the president, because we're flip-flopping, of the United States, then the person is male. Now, of course, this is false because women can also be a president. Now we're going to go into the different ways of our conditional statements are written. We have the original, the conditional statement, if P, then Q. Or we can use this symbol, which is kind of like a directing arrow. P is directing us to the conclusion. The converse takes our conditional and flip-flops it. If Q, then P. Or we can flip-flop it this way using our symbol. The inverse takes the conditional, so the P is still first and the Q is still first, and it negates both of them. So if not P, then not Q. And a contrapositive takes the converse so that the conclusion comes first and then the hypothesis and negates both of those. So I have not Q, then not P. And the logic, these two, the converse and the inverse, are logically equivalent, meaning that if I were to fill in a truth table, they will be the exact same in every truth value. Same with conditional and contrapositive, which makes sense. If I have P then Q, all of those will match exactly if I have not Q and not P. And those are logically equivalent. So if I come down here, I'll show you the to fill in the truth table. So I have all of my propositions, P, Q, not P, and not Q. So I need all of my combinations. I can have true, true, which means not P is going to be false, and not Q is also going to be false. If I have P being true and Q being false, remember the not means it flip-flops, then I have false, and then the opposite of Q would be true. And then down here I have P being false because I've done all of my my trues with P. So my combination will be false or true with Q, and then again flip-flopped. So P is false here, so not P is true. Q is true, not Q is false. And our last one, false, false, which means the opposite will be true, true. Now some of you are thinking, you talked about having the number of options for the different propositions. In this case, I showed you that we had P, Q, not P, and not Q, so shouldn't I have done 2 times 2 times 2 times 2? It would be tempting to accept that the not P and the not Q are the same propositions, P and Q still. It's just the opposite. So we only needed the combinations for P and Q, which is 2 times 2, and I only need 4. Let's go ahead and fill in our truth table for the, we'll start with the conditional, then the converse, then the inverse, and last the contrapositive. Now remember, if P then Q has a little different truth table, and if you need to come up, if I have a true, true, then the conditional is true, and so forth. And if it is false, then it's flip-flopped. Okay, so if I have true, true, let's talk about the conditional first. So I have if P, then Q, it's true, the conclusion's true, the whole conditional statement is true. The next one, if P, then Q, true, conclusion, false. So the truth value goes from true from the hypothesis with a false conclusion, the statement is false. And the next one, if I have a false proposition and a true statement or a true conclusion, remember it doesn't matter what the conclusion is. If the person's not elected, then we can't prove that they weren't telling the truth. So the statement is true. And here I have false proposition, false conclusion, but remember, I can't say that that person didn't have the right intent. We can't prove that they weren't going to have the wages increase, so the whole statement is true. The next one, converse, if Q then P. So now I'm going to look at the truth table a little backwards. So to find the truth value of my converse, I'm going to look at the Q first for the proposition, and then the P for the conclusion. True, hypothesis, true, conclusion, true statement. Now let's go on to the next one. So if I have false proposition and a true conclusion, remember if it's a false proposition, we can't say anything other than it would be true. The politician didn't break their promise. The next one, if I have a true proposition and a false conclusion, that means the person was elected and wages didn't go up. Well, in that case, they broke their promise and the statement is false. And the last one, false, false. The tricky one, if the proposition is false, the whole thing is true because we can't prove that otherwise it wouldn't have been. Now the next one, inverse. Not P, then not Q. So I'm going to come over to my not P and my not Q, and I'm going to go in this direction. Not P, not Q. So not P is false, not Q is false. Again, the tricky combination of false, false gives me a true. Now I want the next one, not P and not Q. So not P is false, not Q is true. Remember, if it's a false proposition, the whole thing is true. And the next one, true and then false. The person was elected, but they didn't follow through the conclusion, so the conditional statement or the if-then statement is false. And now the last one, true, true, of course is going to be true. And notice how these line up nicely. True, true, false, true. That's what it means to be logically equivalent. Now let's move on to the contrapositive. This is not Q, then not P. So I'm going to start with not Q and think of it as the proposition being false and the conclusion being false. Then the whole thing, I know it's true. Now the next one, looking at it backwards again. So the proposition is true, or the hypothesis is true, the conclusion is false. That means that the person was elected, but wages didn't increase, they broke their promise, and it's false. The next one, false, the person was not elected, but wages went up, it still doesn't matter. We don't have a way of saying that they wouldn't have supported their promise, so the statement is true. And of course, if I have true, true, then it's true. But I am looking at it from Q and then P because the Q is the antecedent and the P in this case, or the not P, is the consequent. And just a quick note, these are logically equivalent, where we have true, false, true, true, and true, false, true, true. Logically equivalent, you're sharing the same truth value. All right, well done on your first section, your first lecture. I hope you join me again for the next one.